Dear students, welcome to our class on JRF, SRF, Net 2022. Specialized subject Agriculture Meteorology, Lecture 4. Now, in this class, we try to understand, as I said in the third class also, general meteorology, general climatology, agricultural climatology, micrometeorology, weather forecasting for agriculture, crop growth models, evapotranspiration, climate change, all these bits in a systematic way. I tried my level best to arrange them. Now, the first question of today's class is number one question of today's class is statement A and reason R. Okay, this is the question. Statement A, assertion. Okay, statement assertion, reason for that. What is the reason? Now, assertion statement: cyclones doesn't form between 5 degrees north and 5 degrees south latitude. Cyclone doesn't form. That's 5 degrees on both sides of the equator. That is the statement A, assertion. Reason: Coriolis force in the equatorial belt is either zero or very weak. Now, I explained here. Equator is there. To the northern side of the equator, we call it as the northern hemisphere. The northern hemisphere is also known as land hemisphere. Now, the southern side, it is the water hemisphere here. Over the equator, okay, the Coriolis force is very weak. Coriolis force means, the force, okay, because of the rotation of the earth, because the force acting on the atmosphere because of the rotation of the atmosphere, rotation of the earth is known as Coriolis force. Now, so the first statement is cyclones won't form between on both sides of the equator of northern and southern hemisphere 5 degrees. Now, second statement is because Coriolis force is weak. Now, the answer is both A and R are true, and R is the correct explanation of A. Once again, I would like to impress upon you that cyclones. Okay, right. So, in Caribbean Sea, they are known as hurricane. Now, cyclones are the, okay, first there is a small depression, okay, low pressure and everything. I have explained to you several times. So, the possibility of cyclone between 5 degrees north and south of the equator is very remote because the Coriolis force is weak. Now, second question. What will happen to thermal conductivity of a soil? Soil is there, thermal conductivity, okay, when soil particle size is reduced, okay, when the soil particle size is reduced, the thermal conductivity decreases. You know the equation. I don't want to go to again that 4 years law and okay, Newton's law of viscosity, 4 years law of thermal conductivity, all these things I explained extensively in micrometeorology. Now, question, application. So what is application? When particle size is reduced, what will happen to thermal? Okay, what will happen to thermal conductivity of the soil? Okay, thermal conductivity reduces or decreases. This is the answer. The heat conduction within a soil profile is better when the soil moisture content is. Please note that in a dry soil, the heat flow is very weak, not uniform. Now, when moisture is given, when how much moisture? 10%, 12%, 15%, 20% moisture is given, for example. In which condition? Because 20% moisture is very okay, in between the permeability point and field capacity, it holds everything. So heat conduction is very smooth when the soil moisture content is around 20 as compared to 8 or 12. That's what. Now, so thermal diffusivity, again a question. Thermal diffusivity is the ratio between thermal conductivity and, this is the definition of thermal diffusivity. What is the definition? Thermal diffusivity is defined as, okay, the ratio between thermal conductivity and volumetric heat capacity. This is the answer. So, definition of thermal diffusivity in the form of a question. What is again, once again, for your academic interest? Thermal diffusivity is the ratio between thermal conductivity and dash. For example, dash is volumetric heat capacity. Now, list 1, list 2. Okay, list 1. In the list 1, A, B, C, D. List 2, Roman letters 1, 2, 3, 4. Answers. Numerical 1, 2, 3, 4 you will give A, B, C, D, A, B, C, D, A, B, C, D, A, B, C, D. Now, in the list 1, rice, wheat, maize, peas. Now, minimum cardinal temperature. Okay, minimum cardinal temperature. Rice, wheat, maize and peas. Now, for the rice crop, the minimum cardinal temperature is 10 to 12. For wheat crop, the minimum cardinal temperature is 3 to 4.5. The minimum cardinal temperature for maize is 8 to 10. And finally, for peas, the minimum cardinal temperature is 1 to 2. Okay, these are the answers. Now, in the reduced ceiling method, where T maximum is less than or equal to T ceiling, then what will be the value of GDD? Going degree is a very interesting question. What is GDD? Please tell me. GDD is equal, it is a summation of T maximum plus T minimum by 2. That means the average temperature of the day minus, not plus, minus TB. What is TB? Base temperature. Base temperature is the temperature below which no physiological activity takes place. Now, here the question is, the reduced ceiling method, in the reduced ceiling method, where T maximum is less than or equal to T ceiling. We have kept a ceiling. I worked extensively on that one, T ceiling. Then, what will be the value of GDD? The GDD value here is the summation of T maximum minus T base. T maximum minus T base. It is not T maximum plus T minimum by 2. It is a T maximum minus base. So, GDD value. Now, which of the following weather parameters affects the horse sickness disease in transition? So, heavy rainfall, okay, followed by drought causes horse sickness disease. So, what is the optimum cardinal temperature for rice? For rice, for most of the crop, 30 to 32. Rice also is not an exception. The most cardinal temperature for rice, for maximum production or optimum yields is 30 to 32, 302 to 3032, 302, 32. Now, the another question is the Chavity issue. Very interesting thing, very simple. The chaotic nature of many flows, so many flows are there. Now, Newtonian, non-Newtonian, what are so many flows are there. In a chaotic nature of many flows in the atmosphere, in the form of irregular variations in the velocity, okay, the temperature and concentration about a mean value in space and time is called turbulence. What the turbulence definition is given? What is the definition of turbulence? Turbulence is defined as the chaotic nature of the many flows in the form of irregular velocities, okay, in the irregular variations in the velocity, that is temperature and concentration about a mean value in space and time. It is what is called as the turbulence. So, turbulence definition is given as a question. Now, next question is in case of C3 plants. What are the C3 plants? C3 plants are wheat to rice. Okay, now, so in case of C3 plants, when PAR intensity increases, okay, what happens to the PAR conversion efficiency? What is the PAR conversion efficiency? The PAR conversion efficiency is low for C3 plant when PAR increases. So, they cannot use much of the solar radiation. Okay. However, in case of C3 plant, exactly reverse. Now, once again, I read the question. In case of C3 plant, when the PAR, photosynthetic active radiation intensity increases, for example, rice and wheat. Okay, when PR increases, so never expect there is an increase in the conversion efficiency of PAR into radiation efficiency, in other words. So again, list 1 and list 2, some parameters are given, and the some parameters, whether direct parameters or derived parameters. So some units are given. Say for example, here radiation use efficiency grams per megajoules. In my both PG and PH, I work on radiation use efficiency. Okay, what are the units? Grams of dry matter produced with megajoules of energy. Okay, that is the unit. Now, second thing is the photosynthetic photon flux density. So, what is photosynthetic? What is the unit of measurement of photosynthetic flux density? Okay, micromole per meter square per second. Micromole per meter square per flow. Flux means flow. How flow is given? Micromoles per meter square in a meter square meter area in 1 second. How much flow is there? We call it as the photosynthetic photon flux density. The unit is micromole per meter square per second. Now, Reynolds stress, it is a stress. Force per unit area, that is the pascals, and Reynolds number, shear stress pascals. Reynolds number is the unitless number. Reynolds number, okay, Richardson number, Nusselt numbers, these are all non-dimensional numbers. Please note, in micrometeorology I covered extensively. Please subscribe to our channel, Agrometeorology Farmers and Rural. Go to micrometeorology. Again, I am going to add wonderful applications of micrometeorology in the days to come. See, all these things I had given there. And again, for your academic interest, radiation use efficiency, the units are grams per megajoule. Now, so photosynthetically, photon flux density, micromole per meter square per second. Shear stress, it is the pascals. Reynolds number is a dimensionless number. The ratio of internal force to viscous force, is known as, the ratio of internal forces to viscous forces is known as Reynolds number. Penetration of solar radiation is maximum during, early in the morning and early in the evening. This is a trickish question. A crop is there. The solar radiation penetration is maximum both in the morning and as well as in the evening, because sun is either on the eastern side during the morning, during the it is in the western side during the evening. So most of the sun's rays penetrate to a greater extent into the plant surface, whereas in the most of the students answer it is penetration more during the midday. It is wrong, because straightway the solar radiation is falling, but from the angles, it is wonderfully spread over. Most of it penetrates into the crop canopies. This is the answer. Now, a few more bits for your academic. Which of the following term is associated with the Beers-Lambert's law? What is the Beers law? The relative radiation intensity decreases exponentially with increasing leaf area. That is the Beers law. Beers-Lambert's law. So, Beers-Lambert's law is related with the extension coefficient. Beers-Lambert's law is related with the extension coefficient. That is the answer. Which of the following method relies on measurement of the fluctuating components of wind within a constant flux region of the surface boundary layer? So, Eddy covariance method. I had explained extensively in my micrometeorology classes. Please subscribe to our channel, Agrometeorology Farmers and Rural Development. Then straight away go to micrometeorology. There I have published short videos. So now the question and answer once again. Aerodynamic. Which of the following method relies on measurement of the fluctuating components of wind within a constant flux region of the surface boundary layer? Is the eddy covariance method. It's a wonderful method. Even though the instrumentation cost is high, eddy covariance method is the best one for what? To measure, fluctuating components of wind. This is the best method. Now, which of the following indicates the reference crop evapotranspiration? There are excellent videos by me in our channel, YouTube channel. Please go to evapotranspiration and see what is evaporation, what is transpiration, what is evapotranspiration, what is actual evapotranspiration, what is potential evapotranspiration. See, all these things I have covered extensively. Now, here the question is, which of the following indicates the reference crop evapotranspiration? ET capacity of the atmosphere. The evapotranspiration capacity of the atmosphere is referred as a reference crop evapotranspiration. What are the reference crop we use? Usually grasses, alfalfa. So because by taking into consideration ET capacity of the atmosphere, reference crop ET we determine. Now there are two statements here: assertion A, reason R. Assertion A: the required conditions for evaporation to take from a bare soil surface are the supply of energy and the supply of water to the soil surface. Supply of energy means, heat. Supply of water, these two for a bare soil. That is the statement, assertion 1. Reason: the magnitude of the process, the process of evaporation is inversely proportional to the vapor pressure gradient. Now, the answer is A is true. What is A? For a bare soil, from a bare soil, how? Evaporation occurs. It occurs on two major factors. Number one, the amount of heat load that is available, the amount of water that is available. Now, what is the answer we have given? Reason, first statement is correct. Now, the reason is given is that the magnitude of the process is inversely proportional to the vapor pressure gradient. No, it's not depending upon the vapor pressure gradient. Vapor pressure gradient may be one of the, but however, several factors are the wind speed, the evaporative power of the atmosphere, etc. These are all the things. That's why reason is wrong. Now, once again, I will read. Assertion A is correct. What is assertion A? The required conditions for the evaporation to take place from a bare soil surface or the supply of energy and supply of water to the soil surface is correct. Assertion is correct. The reason is wrong. What is the reason? The magnitude of the process of evaporation is inversely proportional to the vapor pressure gradient. It is directly proportional to the vapor pressure gradient. It is direct. That's why reason is wrong. Now, which of the following method is used for measurement of actual heat? We wanted actual heat. So, okay, in this class, in the previous class, I told the best method for measurement of evaporation and transpiration in a crop field is the lysimeter. The answer is lysimetry or lysimeter method. Now, once again, I read the question. Which of the following method is used for measurement of actual heat? Actual heat, when you go to the field and then lysimeters are embedded in the soil, in the crop field. Crop is also there over the lysimeter in the field. So very big lysimeters are there. Now, so actual E, actual T, we can see from the lysimetric method. The last question for today's class is under a given soil and water condition, total water loss from a grassland into the atmosphere is called as, it is called as the actual evapotranspiration. Once again, I would like to impress upon you the definition of EIET. Under a given soil and water condition, total water loss from a grassland into the atmosphere is called actual evapotranspiration. So these are all the things that I would like to share with you. We meet in the other classes. Thanking you very much for your very patient hearing.